Okay, 1.3 modeling quantities. So here we're going to talk more about units and how we can use units and ratios. So starting off, we have a definition. A ratio is a comparison of two quantities. So normally we use a colon. I think that's what it's called whenever you have the two dots that are right above each other, right? So we have here written A to B, and that's how we'd read that. We'd read this as the word to, right? A to B and C to D. So that's a ratio. Now, a proportion is a different way of writing a ratio. It's an equation statement stating that two ratios are equivalent. Okay. Now, we need to look back up here at the ratio. We have A to B written like that, or we could have this as A over B and C over D, right? Those would both be good ways to say that. So proportion, it's two ratios with an equal sign. All right, there's our definitions. Moving on. Oh, and one more thing. On Classroom, you should have this page here, something that looks a whole lot like this, with a bunch of different units on it. It would be a good idea to either print this off or just have it handy. And another unit or another conversion that is good to have is 1 gallon is 16 cups. I didn't see it written there, but I think it's a good thing to know. So let's look at number 1. We're supposed to solve this. Now, I know there's a couple different ways that people like to do that. Some people call one of them the butterfly method. The way that I look at this is I have my variable, and I want to do as little amount of work as possible to get my variable by itself, right? As little amount of work as possible. So I have x divided by 4. To get my x by itself, all I need to do is multiply by 4 on both sides. So I'm going to have, well, x equals 9 over 12 times 4. I look here and I can take, well, my 4 and my 12 can cancel to be a 3. So now I have x equals 9 over 3. And 9 over 3 cancels to be just a plain old 3. So our answer is just 3. Number 2, are the equations equal or equivalent? So I have a over b equals c over d, and AD equals CB. Now what I'm going to do is I'm going to take this first one here, and I'm going to see if I can turn it into the second one. So I have A over B equals C over D. Now we've all probably seen people draw fractions like this, right? Where they've got, it makes a little bit of a butterfly. That's what we're going to do here. So I have here on the left, AD equals CB. And that is what was written over here. So we're good. So the answer is yes. Now I want to talk just real quick why that butterfly piece works. Over here, if I were to multiply both sides by d, then on the right side here, those d's would cancel. In the same way, I can multiply, well here, let me write this. So now what I have here is AD over B equals C. Now what I can do is I can multiply by B on both sides. On the left they cancel, and I'm left with AD equals CB. Right? This, what I just showed you, is the long way around of what we did really quickly with the butterfly method, or whatever people like to call it. So the equations like that are equal. Next up, the word rate. A rate is a ratio of two quantities using different units. An example rate would be miles per hour. It's a ratio of quantities using two different units, or using different units. I guess you could use more than two. All right, number 3. Here we're wanting to convert between some different units. There are 16 cups per gallon and 8 fluid ounces per cup. Use these rates to convert from 4.8 gallons to fluid ounces. Now there's different ways we can approach this. What I'm going to do is I'm going to use conversion factors, and I think that's the most tried and true way. And I know that it's used sometimes in science classes, so I think it's good to use it in math classes too. Now what we do with a conversion factor is we make a fraction, or we make a rate that really is something like 1. It's equal to 1. Now let me show you what I mean. This tells us that there are 16 cups per 1 gallon. So I'm going to say, well, 1 gallon equals 16 cups. Now, if I were to write that as a conversion factor, I could write it two ways. I could say 1 gallon over 16 cups, or I could write it as 16 cups over 1 gallon. Now we want to think about this for just a second. We know that 1 gallon is 16 cups. So what I'm writing here is this is just the fancy number 1, right? We know that if we ever have something where we've got like the number 4 over 4, that's just a 1, right? They cancel out to be 1. So what we're going to do here is we're going to take our number, what do we have? 4.8 gallons, and we're going to multiply by one of these conversion factors to change its units. Let me write my other conversion factor while we're here. We've got 8 fluid ounces per cup. So we say, well, we've got 1 cup is 8 fluid ounces. So we could write this as 1 cup over 8 ounces, and I'm just going to write it that way, or 8 ounces over 1 cup. Okay, so we have two different conversion factors here. So I'm going to start off with what they tell us. They tell us that we have 4.8 gallons. And we want to end up with ounces. What I'm going to do here is I'm going to find gallons, and I want to pick one of these two conversion factors that would cancel out gallons. So right now we kind of think about gallons are on top of a fraction. So I'm going to pick something where gallons are on bottom so that they cancel. So I'm going to pick 16 cups over 1 gallon. Now looky here, we've got 1 gallon and gallon, they cancel. And that's how a conversion factor works. It cancels out one of the units, and we're left with a different one. Okay, now I'm not going to finish yet. So now I have my thing in cups, right? This is listed in cups. So if I were to multiply out, I'd have cups. But I want to finish in ounces. So next up, I need to pick one of these two that would cancel out my cups and give me ounces. So I need cups in the denominator and 8 ounces in the numerator. So now my cups cancel, and I've got ounces. Now that I've written it all down, I'm going to multiply across. So it happens to be the denominators here are all 1, so I'm going to type in 4.8 times 16 times 8, and I get 614.4, and we're talking about ounces. All right. Now, there are ways to do this maybe a different way. Maybe this specific problem could be done a little bit simpler. But later on, whenever measurements get a little bit more complicated, a little bit more difficult to understand, it's really good to understand how conversion factors work. So again, we've got the statement here that two things are equivalent, and then we have two different fractions that are really just reciprocals. They're flipped over versions of each other. So that's that. Let's look at number 4 now. An entrepreneur, well, let me open this before. An entrepreneur wants to rent a billboard that is at least 25 foot tall to display an advertisement for her business. She is 5'3" tall and casts a shadow that is 7 feet long. At the same time, a billboard casts a shadow 35 foot long. Is the billboard tall enough? So here we're talking about shadow problems. And normally shadow problems, we want to draw a little bit of a picture. So I've got my billboard, and I'm just going to call this is my billboard. Okay, we're looking at it from the side. And then here's the person over here. They both cast a shadow, right? How tall is it? The billboard needs to be 25 foot tall, but she doesn't have a tape measure to measure how tall it is. She is 5'3", so here I'll put 5 foot 3 inches, and casts a 7 foot shadow. At the same time, a billboard casts a shadow that is 35 feet long. Is the billboard tall enough? Well, for starters here, we have some different units. We have her height is in 5 foot 3. We need to convert that to feet. We know that 3 inches, how much of a foot is that? Well, it would be like 3 over 12, right? Because there's 12 inches in a foot. 3 over 12 is 1/4. So she is she is 5.25 feet tall, right? 5.25 foot tall. We're going to call the billboard X feet tall. So here we have X over 35, right? That's the billboard. We want to put that equal to her. She is 5.25 over 7, right? On top, we have the heights of them, right? How tall the billboard and how tall the person. And then on bottom, we have how tall their shadow is. Now we want to solve for our X, so I'm going to multiply both sides by 35. And I'm just going to type that in my calculator. I'm going to say 5.25 divided by 7 times 35. And I got X equals 26.25. So the billboard is 26.25 foot tall. And let's look back at our problem. A billboard casts a shadow. Is the billboard tall enough? Well, what is tall enough? An entrepreneur wants to rent a billboard that is at least 25 feet tall. So is the billboard tall enough? Well, the billboard is 26 feet tall, so yes. Yes, it is tall enough. All right, that's that. Let's look at number 5. Faucet A leaks at a rate of 21 liters per day. Faucet B leaks at a rate of 30 drips per minute. Which faucet leaks at a faster rate? And it tells us that 1 liter is 4,000 drips. So we've got faucet A is already in liters per day, so let's just leave that as is. So we've got A is 21 liters per day. We're going to convert the faucet B into liters per day. So faucet B drips at 30 drips per 1 minute. And here I'm going to use some conversion factors. So starting off, let's look at our time, our units of time. We need to convert minutes to days. We know we can go to hours. We know that 60 minutes is 1 hour, right? I'm using the conversion factor. I'm saying that the top 60 is equal to the bottom 1 hour. And then next up, I can say, well, now I'm in, what is this? Minutes and minutes cancel, so I'm in hours now. To get hours to days, I need to use 24. So 24 hours is 1 day. So I can cancel my hours out. So now I'm in days. And you know what? I'm going to go ahead and multiply these out. So I've got, what is this? 30 times 60 times 24. This gives me, what is this? 43200. This is drips per day, per 1 day. Now I need to convert drips into liters. So next line I'm going to say, well, 43200 drips per 1 day. I need a conversion factor, and I'm going to get it from this equivalence statement. So I'm going to make a fraction. It's going to have liters and drips. I'm going to put my drips on the bottom of the fraction. That way that it will cancel. So I have 4,000 drips per 1 liter. So this will cancel my drips out, and then I'd be left with liters. So whenever I multiply this out, I'm going to say 43200 divided by 4,000. And this is 10.8. And what's my units? It is liters per day. So I'm going to put that back up here. This is 10.8 liters per day. So here I have 21 versus 10.8. So the question at the beginning was, which faucet leaks at a faster rate? Faucet A. A leaks more. Or we could say it leaks faster. All right, that is that. Make sure that you kind of get the conversion factors. There's lots of other videos on YouTube that might be able to help it out or help you out. And if you're still confused, shoot me an email and I'd be happy to help you. All right, so that's that. Make sure that you on Classroom look at this, our conversion sheet here, or you could just Google conversion sheet, or what did I call this? Metric conversion charts and table. You're welcome to just find any of these that you like. I assume that they're all, I mean, we have to hope that they're all right. And I also just on Google, I sometimes type in like gallons to cups, and it will tell me what the conversion factor is. So, all right, that is that. That is 1.3.